up or down, or even put in emojis by using the green React button. After the teacher has shown you how to do a step, click on the Exit Full Screen button to make the video go back small. Try it now. Okay, that's it for the instructions. We can't wait to see what you create. And remember, you can always come up with your own ideas and add them into your project. If you do want to share your project and your own ideas, you can do that using the purple button at the bottom of the lesson. We often show the best ones at the start of the next class. Okay, today's lesson is going to start in a few minutes, so strap in and get ready to code. Hey everyone, we'll be starting the live lesson shortly, but before we do, let's go over a few instructions on how live lessons work and how you can join in. First of all, let's talk about the teacher's video box. This is the video box that I'm in and that you're looking at right now. This is where the teacher will share their screen and show you what to do. When the teacher is showing you how to do something, you should make this video box go into full screen by clicking on the full screen icon here. Try it now and this video should get bigger and cover your whole screen. When the lesson starts, you will see all the steps for the lesson appear here. These are the steps you need to follow to create the project, and the teacher will guide you through each of these step by step. Though if you wish to go ahead and follow them yourself, that's no problem. You will normally be working with two tabs, one tab for the instructions and one tab for creating the code and your project. When you have completed a step, come back to the Instructions tab and click on this green Done button. You get an award and learning points for each step you complete. Under the video box, you will see what step the teacher is currently on. Under that, you will see the chat feed. The chat feed shows you how everyone is doing, and you can put your own entries into it by clicking on the blue chat button and entering your question or message. Or you can give a quick thumbs up or down, or even put in emojis by using the green React button. After the teacher has shown you how to do a step, click on the Exit Full Screen button to make the video go back small. Try it now. Okay, that's it for the instructions. We can't wait to see what you create. And remember, you can always come up with your own ideas and add them into your project. If you do want to share your project and your own ideas, you can do that using the purple button at the bottom of the lesson. We often show the best ones at the start of the next class. Okay, today's lesson is going to start in a few minutes, so strap in and get ready to code. Hey everyone, we'll be starting the live lesson shortly, but before we do, let's go over a few instructions on how live lessons work and how you can join in. First of all, let's talk about the teacher's video box. This is the video box that I'm in and that you're looking at right now. This is where the teacher will share their screen and show you what to do. When the teacher is showing you how to do something, you should make this video box go into full screen by clicking on the full screen icon here. Try it now and this video should get bigger and cover your whole screen. When the lesson starts, you will see all the steps for the lesson appear here. These are the steps you need to follow to create the project, and the teacher will guide you through each of these step by step. Though if you wish to go ahead and follow them yourself, that's no problem. You will normally be working with two tabs, one tab for the instructions and one tab for creating the code.
Hello everyone, this is Radhika from Coding Ireland and welcome to yet another session of Code Along classes. So these are live classes that happen weekly where we all learn a great game or an animation in Scratch, Make Code and other things as well. So today we have a very interesting project with us. Now, all of you know that with everything going automated, with robots and computers all around us, even cars have become automated. So yes, today's topic is self-driving, or what we call as autonomous cars. Now, I'm not sure how many of you are already familiar with it, but in some states of US, like Austin and Phoenix, self-driving cars are already running, and let me show you how they work. So let me show you a small YouTube video. So basically, this video does show a person sitting in front, but it's just for the video purpose. This car actually drives itself around the roads without hitting any other vehicle or any pedestrians. It knows when to stop on the red lights. It knows when there is a turn and when it has to turn. So if you're wondering how it's possibly done, it's because of motion sensors and multiple cameras attached to the software of this autonomous car. As you can see on the right side, we have various camera angles that the car uses and then understands through something called artificial intelligence, and then navigates its way through the roads. Now, these are fully functional and do not require a single human being to be inside them. So, in today's class, what we're going to do is we are going to make our own autonomous car. And let me just show you how it's going to look like. So, just give me a minute. All right. So, if you guys can see my screen, so we would have a car around here that you can see is able to detect when to turn. So we have a black track, and the green grass basically denotes the land, and the car is moving at a speed of 5. So if I just zoom in on the car, you can see that we have some 3 colored segments that we have on the car. These are basically the motion sensors, the detectors that will tell the car what lies in front and sides of it. All right, so let's get going. Let's make our own car now. So we have 2 people as of yet. Slowly more people will join us. And guys, whenever you join, new coders, whenever you join us, you can always rewind the live lesson and go back and see the instructions that I've given, and you can complete the lesson at your own pace and then join me in real time when you're at par with me. Also, if you have any doubts or you want to react something with the emojis, you can always use the react button just like over here, or you can send me a message in the chat box and I'll do as soon as possible. All right, guys, so let's begin the lesson. So I already told you what autonomous cars are. You can also read this article at your own time later on. All right, so with that, I mark step 1 as done. And we get a user astronaut. All right. Okay. Step 2 is now we have to create a new Scratch project, guys. So open a new Scratch project with the link over here given below and create a new project. Okay. That's it. You can give your project a name. I'm going to call it, say, autonomous car. And that's it. So that's all with step number 2. And we get a compass. So what do you guys think that does a self-driving car use a compass to know its directions? Let me know in the chat section if you think there is somewhere a compass involved in the software. All right, guys. So now we have all right. So the next step that we have to use is we have to add the car sprite. Now, let me just show you what the car sprite is. Guys, you will have to upload this car sprite that we have provided you in the platform. So to do that, let me show you how you have to do it. So this is the car sprite. and we have red, blue, and yellow motion sensors over here. As we proceed, I will tell you what these will do. As of now, just click on this image, right click, and save the save the image in your computers or laptops. I have in my download section, it's by default, its name is Steps AC Car. You can call it anything. Save it, and then go back to Scratch. Delete the cat sprite, we do not want it. Click on the cat plus option, click on upload sprite, and go to your saved location. Click on the image, open, and we have the car sprite in our project. Okay, guys? So with that, I mark step 3 as done, and we get a cloud sun. It's so cold over here where I live, and I am actually expecting, I am hopeful for the sun to be around soon. It's so chilly. All right. So I hope no doubts still here. Now I'm going to go to step number 4, and we're just going to adjust the size of the car now, guys, because of course it's very big compared to our stage. So we are going to do it using the code blocks and not using the size operator. So what is the difference when we use when we change the size from, let's say, here, or when we change the size from the looks, when we say set size to let's say 20? Okay, so what is the difference? What do you think? Will it go to 20 or will it go to 60? So always remember that whatever you mention in the coding block will always take priority over what you write over here. Okay, so it's always better to use the coding block, so that even if you change something over here to test something, then when you run your code, it's always back to the size that you want. Okay, and we can use these for a little bit of a test purpose. I'll show you guys later on. Okay, so for now, for this project, we want the size to be 20, so you can just set the size to 20. Over here we have set it to 10 actually in the lesson description, but uh, you guys can adjust it between 10 to 20 depending on the track that we will be drawing. Okay, so as of now, okay, let's just go keep it back to 10 and we can adjust it later on. Okay, with that, we mark step number 4 as done, and we get an X. So since it's autumn and we are running the autumn series, so we get everything related to the autumn season. Okay, now we have the car. Now we want to draw the track for our car to move. All right, so what we're going to do is we are going to draw our own track. We are not going to use any of the existing backdrops. So go to backdrops and click on paint. We are going to paint our own backdrop. So delete this backdrop. So we have backdrop 1. All right, so backdrop 1. Click on convert to bitmap and click on the paint fill option. And now choose a shade of green. So you guys can choose whatever you want. All right, and here we have a shade of green. Next up, we are going to draw the black track. For that, choose the paintbrush icon and make its width, or you can say the size of the brush, to be a little big. As you can see, okay, first we need to choose the black color as well. So to make any color black, you can just set the brightness to 0 for any of the existing colors that you had, and you will get black color. So this is a little thin, so I just did an undo, and make your brush size a little bit thick, whatever you think is appropriate. Okay, and you can just make a track of whatever shape you want. So I'm just gonna make it. Okay, I actually went out of the stage, so I'm just gonna make it a little better. Okay, you guys can just make any rough track. All right, this seems fine. Okay, and we have our track. Okay, so let's see how our car is looking. It does look good. Now I see that the size is also perfect for the track. Okay, and that's it. So click back on your car sprite so that you can get the code blocks related to the car. Okay, when you click the stage, you will get all the coding blocks related to the stage. So you have no motion because the stage doesn't move. So just click back on the sprite and you have all the sprite blocks. So that's it. If you have any doubts, guys, let me know. So we are done with step number 5 and we get a planet ringed. So do you guys know which is the ringed planet in the solar system? Let me know in the comment section if you know the answer and I'll give you a huge shout out. Okay, meanwhile, let me see if anybody has any issues. Okay. All right, I think we are good to go. Oh, so Purple Leopard 2 says Saturn. Yes, Purple Leopard 2. That's a unique name. And you're right. Yes, it's Saturn. Very good. And do you also know how many rings it has? Let me know if you know that as well. Okay. So, meanwhile, I'm going to go to step number 6. Now that we have the car, we have the track, we are going to place the car rightfully on the track. Okay. So, what you guys can do is just pick up your car and drag it and put it to any starting position over here. And guys, I'm going to make my car to 15. You guys can adjust it based on the thickness that you have made on your track. So I like it to be 15 so that I can at least see it properly. But don't make it too big. Make it the size should be such that you can see the black track on either side of it. Okay, now that I have it, just programmatically we will do it. Now choose the go to xy block. Now guys, notice that the go to xy block will tell you the position of your sprite. X and y tell you the position of a sprite on the stage. So notice that when I move it, the x and y change automatically in the go to block. So what you have to do is you just place it wherever you want and then just drag this block out and put it over here. So what will happen now is that no matter where you drag it by mistake, let's say, if you click the green flag, it will automatically set it to this position. Okay, so far so good. And also we are going to point its direction uh, to 90, and 90 means it's pointing towards the right side. So you can see that as the car will move, it will move and it will we will see how automatically it will move and it will change its direction. Right now I'm moving it manually, changing the direction manually so that I can show you guys later on that how it will automatically, the self-driving car will automatically just change its direction. All right, so we do not want it at this direction in the beginning. In the beginning we want it to set it to the direction of 90, and everything related to directions, motions, coordinates is in the motion block and 90. So That's it. Okay. So we have set the initial conditions and we are done with step number 6. Any doubts, guys? No? All right. And we get a bookmark. Now, I don't know how many of you have actually used bookmarks in your life, but when I was small, I did read a lot of novels, and of course, I couldn't finish them in one go. So I used to use a bookmark that I actually created myself and use it. Do any of you guys use it anymore? I think children read Kindle a lot these days. I'm not sure how many of you read hard copies of books. If you do, let me know in the comment section. All right. So now we don't have any doubts, and we are going to go to step number 7, and we are going to create a speed variable. Okay. So right now our car is not even moving, but when we do move the car, we are going to give it the functionality to increase or decrease the speed. Now, you guys know that anything which can change, which can increase or decrease during the course of time of the game is a variable because it varies, right? So, we are going to create our own variable in the variable section. A variable always has a name. Click on make a variable. Let's give it a name called speed. And by default, it sets it to 0, but we are going to set our speed to, let's say, 5. Now, currently, this is not going to do anything, all right? It's not going to move at all because to move it, we need something to do with the motion move block. Okay, so just creating a variable speed and setting it to 5 does not mean that the car will move. Okay, so we will need to actually set the speed into the move block that we are going to do now. So this is done, and with that we are done with step number 7. Oh, I'm sorry. Okay, and we get a grin beam. I don't even, it's an emoji. All right. Oh yeah, it's a famous emoji. All right. So now we will actually drive forward. Okay, so now we will, with this step, after this step, you guys will have achieved the following scenario that you see on the screen. Okay, now we are going to move our car and we are going to make use of the motion sensors. So guys, these 3 sensors, I'm going to tell you where and when we'll use them. So the blue sensor, we will use the blue sensor to check if the car can move forward or not. It's going to check if we have the black track, in other words, if we have the road in front of us or not. So the car will keep on moving forward till we have the road in front of us. That means as soon as it sees the green side, it will stop. Okay, the red and the yellow motion sensors will be used for turning. Okay, that we will do in the next step, but as of now we are just going to check with the blue motion sensor. Okay, so what we are saying is that whenever the sensor, the blue sensor, will, it's going to sense the colors. Okay, so the blue sensor, I'm going to change the speed so that you can see the color. So this blue sensor has to sense the black road. So we go to sensing and we choose the color touching color question. And now all the diamond shaped blocks are give you a yes or a no answer. These are also called booleans. Okay, and the yes and the no question goes with the if blocks in the control section. So as I tell you always, that similar shape goes inside similar shape. So a diamond goes inside diamond. To choose the colors, guys, use the color dropper. Now, if I just press the green flag, you go back to the initial size. And now see, it's hard to pick the color with this size. That is why I told you that use the size block for testing conditions. So make this bigger just to pick the correct color. And now you can easily choose it. No need to strain your eyes. And the blue color is touching the black color. Okay, and we go back. So if it is sensing the black road, we will move forward. And how many steps? We will move forward with the speed that we set to 5. Okay, let's see if this works. So get set, go. So it worked, right, guys? I hope you guys saw that it just moved one time with 5 steps. Were you guys able to see? Let me show you again. Just see it again. I'm going to press the green flag and it moved just once. Now, why did it move just once? Anybody who can think of the answer, try to think, why did it move just once? The answer is, you guys can pause the video and just answer it to yourself. The answer is that when the green flag is clicked, we do everything in order and the if block runs. So the blue color was touching the black color, so we moved, and that's it. The if block will only check the condition once. If we want to check the condition again and again, we need to loop it, and for that we use the forever block. So if I keep on clicking the block again, you can see that it keeps on moving. Keeps on moving, and now it has stopped. Why has it stopped now? Because now the blue color sensor is not able to sense the black color anymore, so it does not move forward. Okay, so let's try that once again. But first, pick out a forever block and put the if condition inside. And now let's check it. Perfect. Okay, so now our blue sensor is working perfectly and the car moves forward. Now is the time for the other sensors to work, and the yellow and the red sensor will now do their job to turn, okay, when there is no more track ahead. Let's see how to do that. Now let me see if this step, okay, for this step we are done. We just had to drive forward. Okay, so this is done. Step number 8, and we get a pen. That's correct, purple lever 2. It's not in a loop. That's why it was not, it just worked once. That's very good. So step number 9 is to make it turn. Now guys, the red motion sensor, now you guys can see that when the car goes straight, even the red motion sensor is not touching the black track anymore. Okay, so now we will see if the red sensor is touching the ground. We actually just want to turn it. Okay, so now what do we want? We want the car to just turn by what angle and in what direction. Guys, pause the video and think for a minute. Now we want to turn it in the clockwise direction, like that. Okay, so we want to turn it a little bit and then move it forward. Okay, So we want to turn it so that, see, you guys can see that I am just turning it and the car is moving on its own. Do you see? I am not even moving it ahead. It's automatically happening. Why? Because when I move the car, let me zoom in. When I move the direction, then the if condition becomes true, where the motion sensor blue touches the color black and the car starts moving forward. Just look at that, guys. Let me zoom in the max, and I am turning it by a small degree. And see, as soon as this will touch the color black, it moves. Okay. So what we have to do is we have to first duplicate this condition, put it below it, and now when the red sensor touches the green grass, okay, now I was manually turning the direction, but here, since it's an automated car, we will automatically turn the car by an angle of 10. Okay, and if the 10-degree angle doesn't work, you can turn it further. Okay, so let's say now which direction? It's the clockwise direction, so we turn it to, let's say, 10. Yeah, so we are turning it to 10. Let's check once again. So now see, it's working. I can set the speed to a slower number so that you guys can see it even better. See, guys, as soon as the blue road was finished, sorry, the the black the black road was finished, the red sensor just turned the car. Okay, if you do not understand this concept, please rewind the video and see again where I have manually showed you where I turn the car. What happens if you just turn it by 2 degrees? Will it still work? Let's see. It works, guys. Okay, the only difference is that the car will move at a lesser angle. Okay, so have you ever seen your parents drive the car? Whenever you have to turn, even if you just turn your car at a little bit angle and move forward, you know, you're able to actually make that cut. Okay, so yes, it works. So but we want our angle to be 10 and we want our speed back to be 5, and it's working. Okay, so with that we are able to turn right. Now with that, our car will drive forward and turn right when the red sensor touches the green grass. So we have done that and we get a tram. Now we have to do the same thing with the yellow/orange sensor to turn left. To turn left, we will take a anti-clock degree turn. Now in this game, we are not turning left, guys, because we are moving in the clockwise direction. But if you make any game where you're moving in the anti-clock direction, then this block will be used. Okay, also this section will be used if let's say your car goes off track and the left sensor touches the grass. So let's say what happens if I put the car like this. Okay, I think it moves. Okay, guys. So, in a situation like this, let's say you run into a situation like this where your blue sensor does not sense the black track, okay, and the red sensor, that means the blue sensor, the car will stop because it does not have the track in front of it. But the red sensor is yet not sensing the grass. That means you are not at the curve yet. In that case, the yellow sensor will work. Why? Because now the yellow sensor is touching the grass. Okay, so both red and yellow sensors will turn when either of them senses the grass. In this case, guys, now in this case, oh, sorry, go back. Now, what we want is that in this case, we actually want the car to turn in the anti-clock direction like this, so that the blue sensors can touch the black road again and then move forward. Okay, so basically all we are doing is that turning them in anti-clock and clockwise direction so that the blue sensor can touch the track again. Okay, so now just go back to sensing, or you can just duplicate this section again, put it below this one, and let's make the car size bigger. Now we want to sense the yellow car. If the yellow is touching the green, then we turn in anti-clockwise direction this time, 10 degrees. Let's see now. Everything is moving perfectly. If you make your track a little thinner, you will notice the yellow sensors being in use. Right now, it's not even, the yellow sensor is not even touching the car. Yellow sensor is not even touching the grass. Let me make the size bigger and show you if it works. Now you guys can see it better. So the car that you see is wavering now because the yellow sensor is turning it inwards towards the left, anti-clock, and the red sensor is turning it inwards towards the right, the clock sense. So red sensor works here, here yellow sensor works, and so on. Okay, but we do not want this jittery motion, so we are just going to make it back to 20, or I think 15 is also fine. Okay, okay, so that our car has a better motion. All right, so with that, our car is now moving left, right, and forward, and we get a quote right. Oh, this is a closing quotes. So let me see if we have any questions, and we are done. So guys, we have actually completed the basic version. Our car is self-driving itself and turning wherever needed. But now let's add a bit of excitement to it by giving it the ability to uh, speed up or speed down. For that, we will use the up and down arrow keys. Okay, so whenever we hit the up arrow key button, guys, these are listed under events. Now, when green flag clicked is also an event. So for those of you who are not familiar, who have not seen the previous classes where we discussed events, so event is nothing but an action that is done or that happens, okay, which it's which triggers something. So when the green flag is clicked, that means we are doing an action, okay, we are doing a trigger, and then we say, okay, when this event of clicking the green flag happens, then do all of this script. Similarly, when the up arrow key is pressed. So when I press the up arrow key on my keyboard, what do I want to do? I want to change the speed. Go back to variables and change the speed by a +1. So let's see, I'm now clicking my up arrow key, guys. You can test it on your keyboards. The speed is going to 18. Okay, and duplicate this block. When the down arrow key is pressed, change the speed by a -1 so that it can go down. So let's test this. Now see, I'm decreasing the speed. Okay, and now I am increasing it back. It's too fast, right? Let's see how much faster can this go. So there is no upper limit because we did not add any such condition. Okay, so now why do you think this wavy motion is happening and now the car has suddenly stopped? With all three sensors on the green track, so basically we are not able to do anything now. And why are we not able to do anything now, guys? Because firstly, okay, I'll tell you why this happened. This happened because the car was now moving so quickly that the code did not get enough time to get executed. Okay, so all these if conditions, it's like it's everything's happening so fast that it's just overwhelming. Okay, and the conditions uh, just could not get executed. Okay, it's like imagine if you're eating food and you eat it so fast that you're not able to swallow it with the speed that you're eating, that you get choking. Okay, you get choked and that's it. Okay, so similarly, to process all that high speed, uh, in order to process all that high speed, the car just crashed. Okay, so it was working all three conditions, it was sensing all three things, but the speed was just too much and we couldn't process it. So what happened, uh, or it just crashed and it stopped. Why? Because all three sensors are now touching the grass. So since the blue is not touching the black track, it's not moving forward. And although the yellow and red are touching the green track and now they are supposed to turn the car, but then they're canceling out each other's effect. The yellow sensor is turning it 10 degrees anti-clockwise and the red sensor is turning it 10 degrees clockwise. So basically they're canceling out each other and the car just stopped. So just watch it again. Due to the speed, the car is just going out of control. And that's it. So in that case, what do we want to do? We're going to do something called reversing the car. But before that, let's mark step number 12 as done. So this is the exact scenario that's explained over here. Okay, so yeah, the reason it was that the sensor code did not have time to make it turn and it just went off track. So now whenever this happens in the real life, that your car is stuck somewhere, so you need to reverse your car. So in order to reverse your car, guys, what do? You move it back a little first and then you turn your car, right? So this is what we're going to do exactly over here. So let's read this out. It says that we can detect if the car has run off the track by checking to see if the blue sensor is touching the green grass. Yes, of course. All right. So the blue sensor is now touching the green grass. That means it's off track. And now we will reverse it. So what do? So if the blue sensor is touching the green grass, that means it's off track. We reverse it. and then we turn it. Now, it really doesn't matter whether you turn it in the clockwise direction or the anti clockwise direction, because both of them are going to solve your problem. Okay, so let's see it manually a little bit. I'm going to show it manually. Okay, guys. So zooming in. Okay, now I'm going to move it -2 steps. So I moved it back. You see what happened? As soon as I moved it, the speed, which was 63, let me set it back to 3. Okay. Now let me set back. I am moving it, and then I also need to turn it. So let me just get the turn block also with me. Guys, please bear with me because it can get a little confusing because I'm zooming in and zooming out. Okay, I'm just making the speed less. Okay, so see. Okay, so I moved it back and now I'm turning it, but nothing happened because still everything is uh, still touching the grass. Okay, doesn't matter. Let me move it back again and turn it. Still, the car is not moving because still all the sensors are touching the grass. Let me move it back again and turn it again. We are yet not touching the track. Move it back again and turn it. Okay. Now, what will happen, guys? Now, the yellow sensor is touching the track. Now, when the yellow sensor touches the track, then what will happen? That it would stop turning 10 degrees. So the cancelled effect that the yellow and the red sensor were doing, that cancelling effect, that would stop happening, and this condition will come true. Red is touching green. Okay, the yellow touching green condition becomes false, so this turning stops happening and the 10 degrees turn happen. Okay, so we basically will now turn 10 degree. As soon as we turn 10 degree, the car immediately comes back into track and the blue sensor starts working and the car will then move forward. Okay, so I'm going to show it to you again. So what we did was, whenever the car went off track like that, and we checked that using the block. How did we check that? We checked that using the blue color. We checked that the blue color, sorry, still not blue. Yes. If the blue color is touching the green color, that means we have to reverse. And to reverse, let's bring out these two blocks together. So we moved back and then we turned. Okay, guys. So since we are in a loop, that means we would keep on moving back and turning back. Keep on moving back and turning back. See, this will keep on happening till one of the sensors actually touches the track. Okay, when one of the sensor touches the track, then one of these conditions will come true, either the red or the yellow, and it will make an even bigger turn and the car will come back into the track. So guys, you can manually do the same things that I am doing so that you can get an even better understanding. Let's check it now. Sorry. Okay, now let me increase the speed. See, I've increased it so much Now let me decrease it and show it to you. So I'm going to manually make the car off track a little bit. See guys, and it came back. Let me manually make it go off track. And see, it just did a reverse and it came back. Manually, it will just turn, keep on turning, keep on turning. I think I just did too much of a reverse. It would not have gone like that if I wasn't doing it manually. Yeah. Okay. I hope it was not complicated. Okay, it's going back because the speed has gone back to -3. Let's go to a proper direction. Okay, that's it. Guys, I hope you guys got it. If not, please send in your doubts. I try to explain it in as much detail as I could. So, in short, we are just using all the sensors. The blue is moving it forward by sensing the black track. Okay. The red and the yellow are turning it left and right if they touch the green grass. And if we run into the scenario of the car becoming off track completely with all motion sensors on the green grass, we test it by checking if the blue sensor is touching the green grass. In that case, we reverse by moving and turning till one of the sensors touches the track back, and we just reverse the car. So that's it. That is our automated car. And I see that Purple Leopard 2 has completed it. That's great. Congratulations. I hope the rest of you are able to do it as well. Now, okay, let me just first mark it as done, and we get a squirrel. All right. So to improve the ideas, guys, so pause the video and think, how can you make it better? Now, I do have some ideas over here. So let me show them to you. So you can use two cars instead of one, and you can see how you can avoid accidents when two cars are moving. Or you can see, firstly, you can try a different track. I've just used like that. Okay, you can try a different track like this. Or let me show you another project where okay, now this is another project that I just made to show you what else can happen. So let's say there's a person crossing the road and the car has to sense that a person is moving and it just stops. Okay, now the other scenario that can happen is now the two cars just bumped into each other and the accident was caused. Okay, so I did not correct this scenario because I wanted you guys to think, how can these two cars sense each other and change their directions so that they can avoid this accident? Okay, so you guys can also think of scenarios like these, or you can place roadblocks like stones or some construction things. You can experiment with different backgrounds that Scratch has, all right, in order to give it a different feel. All of that is up to you, but do try to make it even more interesting and share your projects with us. And we get an astonished face. I hope you guys are not in this scenario right now where you're astonished. I mean, I hope you're happily astonished and surprised, but not in a way that, oh my God, what just happened in the lesson? Okay, so to share your project, just click on share your project, and you have to click on submit your project, give it a name, tell us about it, and the link will come from here. We're on Scratch, click on share, and you will get the link at the top right, bottom right corner. Click on copy link, copy this link and paste it over here and just click on share. So we will see your project in the portal and I will show it to everyone in the next class for all those of you who share it. You can also submit it here in the chat section. All right, guys. With that, we complete the lesson. Uh, I hope everyone enjoyed it. I hope everyone who watches it later will enjoy it. And yeah, I'll see you guys next week with a new coding challenge. Goodbye, good evening, see you next time.